All right, for the second part of the video, we're going to finish the examples. So we're still on permutations. So how many ways can 4 of 7 different kinds of bushes be planted? This would be your R. The 7 would be your N. So you would have 7p4. So 7 factorial over 7 minus 4 factorial. So 7 factorial over 3 factorial. You know the 3 factorial will cancel here, so you just really need 7 times 6 times 5 times 4 because these will cancel as we showed in the previous video. And this will give you 840. Okay, last one, it says that we're having 4 processes and that they can be performed in any order. You want to know how many different orders. So we only have 4 of something. Okay, so a couple different ways to think of it is if you have 4 things and you want to order them. So it could be 4 times 3 times 2 times 1, or we know that's just the same as 4 factorial, or 4p4. So again, any of these 3, they all give you the same answer, which is there are 24 different ways to order them. Now, the other part that we're going to work on is distinguishable permutations. And this formula is a little bit crazy. Okay, so basically, if you were to take the word pass and they told you to find the different arrangements, you have 2 S's. So we can't distinguish between the first S and the second S because they're the same letter. So instead, when we do certain orderings and they have the same letters, we've got to take those out so they're not counted twice. Because this is the same letter, we don't want to count it double because it'll change the value for how many we can figure out. So how many distinguishable permutations are possible by using the letters? So let's show you how this works. So first off, the formula for this is you want the total number of letters. And when you take the total number of letters, you're going to take the total number of letters and do a factorial of it over any letters that repeat. And again, with a factorial. So that's basically what this formula here is saying. So total number of letters. So if we look at Athens, 1, 2, 3, 4, 5, 6. So we have a 6 factorial on top. Letters that repeat, there are none. So we're just going to put it over 1, and 6 factorial is 720. Okay, so there are no repeating letters. So that's kind of boring. Let's try to find one that does have repeating letters. So basketball. So first, total number of letters. So the total number of letters is 10. So that's going to be a 10 factorial over. And now you want to basically go through and circle the letters that repeat. So I've got a B and another B. So I have 2 B's. So you're going to do 2 factorial. And then I also see that I have A's repeating. So A, and there's 2 of them. So 2 factorial again. And then lastly, I see that I have 2 L's, 1, 2, so 2 factorial again. And then basically you will work this math out. So 10 factorial, I'm just going to leave on top for right now. But this is basically 2 times 1, 2 times 1, 2 times 1. So 2 times 2 times 2 is 8. So on the calculator, you'll do 10 factorial over 8 or work out 10 times 9 times 8 times 7. You should get 3,628,800 over 8, which gives you 453,600. Okay. And we continue that process. So 2 more examples and we'll be done with this section. So again, the word substitute, if we count up the letters, there are 10 letters. And then now we go and find the repeating. So S's, 2 S's, so 2 factorial. Excuse me. And then the next letter that we have repeating is a U. So just be careful, they all start to look the same. So 2 factorial again, because there's 2 U's. And then last letter looks like a T. 1, 2, and 3 this time. And so in order to, again, do the math here, so 10 factorial, leave on top. And then this, again, is 2 times 1, 2 times 1. This is 3 times 2 times 1. So this will give us 2 times 2 times 6, so 24. And then again, you can work out the math. So 151,200 will be your total. All right, last one, the word icicle. So there are six letters to start with. And then we have 2 I's, so 2 factorial, and 2 C's. And that looks like that's it for those. And then again, this is just 2 times 1 and 2 times 1. So that'll be a 4 on the bottom. So it'll be a 6 factorial over 4, which should give you 180.